Hey, I wanted to go over the questions you all still had in class that I didn't make it to. So number 102, I just put that completely into my calculator just like it looks, and I made sure I was in radian mode, and it gave me negative 0.9749. So maybe if you had a question on this one, just double check that you're in radian mode. All right, 123A is a word problem. The normal daily high temperature, T, capital T, in Savannah, Georgia, can be approximated by this really complicated equation here, where T, lowercase t, is the time in months, with T equals 1 corresponding to January. Find the normal daily high temperature for each month. So in the problem it says the normal daily high temperature is capital T. So they want us to find capital T for each month, and A part is for January. And in the problem it said let t, little t equal 1. So all we're going to do is plug this thing into our calculator. That's the thing with some of these word problems. They're going to look so confusing. But all we're doing is we're plugging a 1 right here. So pi times 1 over 6 is just pi over 6 minus 7 pi over 6. So if you want to do a little simplifying, you could. That would make what you have to enter in the calculator easier. But if you don't mind adding stuff to the calculator and you're careful, you could just do it all on the calculator. So 1 pi over 6 minus 7 pi over 6 is negative 6 pi over 6. I'm going to get a little fancy here for a second. Cosine of negative 6 pi over 6 is cosine of negative pi. Cosine is even. And since it's even, whoops, I left off cosine of negative pi. Because 6 over 6 is 1. Since cosine's even, cosine of negative pi is the same thing as the cosine of positive pi. So cosine of negative pi is the same thing as cosine of pi because it's an even function. And pi is on my unit circle chart right here with an ordered pair of negative 1, 0. So t is 76.35 plus 15.95 times negative 1. So t is 76.35 minus 15.95. So we can actually do all of this without even picking up a calculator. So t is 13 minus 9 is 4. 5 minus 5 is 0. And 7 minus 1 is 6. If I can subtract, it should be 60.4 degrees Fahrenheit. Now, I did a lot of stuff by hand. You honestly could have plugged into your calculator right here. If you were careful, you could have done all that in your calculator in radian mode. So I'm not going to do B part. Let's see. I will say this about B part. T equals 1 for January in 2010. B part is February 2011. So T equals 1 is January 2010. So by the time we got to December 2010, that would be at December 2010 would be at t equals 12. So February 2011 would be t equals 14. So I will say that about that. So that just means you're going to put a 14 right here in place of t and figure that out. May 2010, that would be t equals 5. June 2011, what's that? That's 4 more months past February. I think that would be t equals 18. All right. Last one we'll look at is 125A. An airplane flying at an altitude of 6 miles is on a flight path that passes directly over an observer. Let theta be the angle of... Okay, let's get some things drawn. We have an airplane. Yay! And it's on a flight path. Let's see. It's flying at an altitude of 6 miles. It passes directly over an observer. So I've got a little person over here, and it goes directly over them. Theta is the angle of elevation from the observer to the plane. So if you have your horizontal, the angle of elevation from the observer to the plane, from the horizontal up is how we always do that. So there's theta. Find the distance from the observer to the plane. Oh, so there's actually a picture here, and this is the distance they want when theta is 30 degrees. And you all asked for A part, so A part is to find the distance when theta was 30 degrees. So if they hadn't had a picture, you might have been curious, do I want this distance or do I want this distance? So if there wasn't a picture provided, I would have said more things. I might have said, find the flight distance. I would have maybe said, find the distance along the line of sight. And that would have let you know I wanted this distance. And then if I had wanted this horizontal distance, I might have said, find the horizontal distance from the person to the plane. But let's see here. We are looking for x. This is right triangle trig. We're going to find the, not the tangent. Oops. We're going to find the sine of 30 degrees equal to the opposite over the hypotenuse. We will cross multiply. We will divide both sides by the sine of 30 to get x by itself. And in our calculator, we'll do 6 divided by the sine of 30 degrees. So we'll make sure we're in degree mode. Let me get in degree mode. 6 divided by sine 30 is 12. I should have known that without picking up my calculator. Sine of 30 is a half. Instead of dividing by a half, let's flip it up there and multiply by its reciprocal. We get that 12. All right, the last thing I wanted to talk to you about was I promised you another, almost dropped my calculator. Promised you another domain and range problem. So, say we have this graph. Get a few little tick marks going. And let's say we have this and this. There's our function. We want the domain and the range. Domain is x, range is y. So for domain, all I want you to do is look along the x-axis from negative infinity to positive infinity. And I want you to go from left to right, just like we read a book. So from the smallest value, you travel along this x-axis and you tell me where you start to get points for your function. So let me get rid of all these black lines. So I'm traveling along the x-axis and I don't have anything going on with my function until I hit right there. Right there. So -1 is my smallest x value, and it's a point. There's not an open circle or anything there, so I use a bracket. And then I get x values everywhere, all the way forever, because of these arrows on the end. It's going to keep going forever to positive infinity, which always gets a parenthesis. Now for range, we're thinking y values. I want you to start at, let me get rid of these. For range, I want you to start at negative infinity and go up to positive infinity. We always want to go smallest to biggest. So you're traveling, you're just getting ready to start traveling on your y-axis, and you might think, ooh, I don't see anything yet. But then you look and you say, oh, that's an arrow. And what's that arrow do? It keeps going down forever. Is anything going to stop it? No. It's going to get all the way down to negative infinity. And then I've got y values, I've got y values, I've got y values. And don't think it stops right here, because it's got an arrow on the end too that's going to keep on going up and over all the way to positive infinity. Last year you probably wrote all real numbers. This is all real numbers, just written in interval notation.